Before getting into the next lesson, try this warm-up question that tests your understanding of the previous lesson, solved by factoring. So pause the video, solve this equation, and come back to see how you did. And this is how I did it. So I rearranged the equation to set it equal to 0 first. I tried looking for common factors, but I didn't find any. So then I noticed this was a complex trinomial. I decomposed the middle term. Multiplies to 5 times 9 is 45. Adds to 18. Well, that's 15 and 3. Now I factor by grouping. For the first group, common factor is 5x. I'm left with x plus 3. For the second group, common factor is 3. The other factor is x plus 3. Now x plus 3 is a common factor. I'm left with 5x plus 3. So this factor times this factor equals 0. Therefore, either x plus 3 equals 0 or 5x plus 3 equals 0. If x plus 3 equals 0, then x equals minus 3. If 5x plus 3 equals 0, then x equals negative 3 over 5. So the final answer to solve this equation, x is equal to either negative 3 or negative 3 over 5, that whole set. In this lesson, we're not just going to look at quadratic equations anymore, but now we're going to look at other polynomials that we can factor and solve by factoring. So by the end of this lesson, hopefully you can solve polynomial equations by applying your knowledge of factoring quadratics. So we're going to build off of what we've done so far with factoring, and we're going to apply it to different polynomial equations. Okay, my first example, x to the exponent 4 minus 11x squared plus 18 equals 0. So remember from last time, when you want to solve an equation like these, you got to make it equal to 0 first, which it is. Now this is a trinomial, but is it a simple trinomial? Well, it doesn't look like it because the exponent is 4 and here it's a 2. I'm used to seeing x squared plus bx plus c equals 0. So my exponents don't look right. However, this one's tricky because x to the exponent 4 is a square number. So I'm going to do a little trick here. I'm going to let a represent x squared. So x to the 4 is actually a squared. And minus 11x squared, well, if x squared is equal to a, then I can rewrite this as minus 11a. So if I finish this off, I end up with a squared minus 11a plus 18 equals 0. This now looks like a simple trinomial. So I can factor it like that. A squared minus 11a plus 18 equals 0. Well, I can factor this. I need two numbers that multiply to 18 and add to negative 11. Well, that's minus 9 and minus 2. Okay, so I had my equation. I factored it. Now I'm going to go back to my original with x because I want to solve for x. That's what I'm trying to do. So everywhere I see an a, I'm going to replace it back with x squared. Okay, so x squared minus 9 multiplied by x squared minus 2 equals 0. Look here, x squared minus 9. That's a difference of squares. So I can factor that. X squared minus 9 is x plus 3 times x minus 3. Now x squared minus 2, it might look like a difference of squares, but 2 isn't a square number, so I'm just going to keep it like this. Okay, so this is my fully factored form now with x. The whole thing's equal to 0, so now I can use my factors to solve for x. So either x plus 3 equals 0, or x minus 3 equals 0, or x squared minus 2 equals 0. If I solve for x in each case, then I get my possible answers for x. Now just be careful here. X squared minus 2 equals 0, which means x squared equals 2. Now here I did x is equal to the positive or negative square root of 2. Watch out for that. It's not just the square root of 2, it can also be the negative square root of 2. For example, if I said x squared equals 25, well, x could be 5 because 5 times 5 is 25, or x could be negative 5, because negative 5 times negative 5 is also 25. So anytime you take the square root to solve for x, make sure you take the positive and the negative square root. So my possible values for x to solve this original equation is x can be negatives of the square root of 2, or it can be negative 3, or it can be positive 3, or it can be the positive square root of 2. They will all give you a correct answer. This next example, 6x to the exponent 4 minus 5x squared minus 4 equals 0. This is actually really similar to the example that we just did. So I'd actually like you to pause the video and try to solve this by factoring on your own, just to test yourself, and then come back and check with me. So I've got it all on the screen here, and I'll just kind of walk you through it. So I did the same thing as I did before, where I let a equals x squared. So x to the 4 is a squared, x squared is a. So now I have my quadratic equation. I noticed that it's a complex trinomial, so I decomposed the middle term. So 6 times minus 4 is minus 24. I need two numbers that multiply to minus 24 and add to negative 5. So that was negative 8 and 3. Then I factor by grouping. The greatest common factor of 6a squared minus 8a is 2a. I'm left with 3a minus 4. Here, 3a minus 4, the greatest common factor is just 1. So just leave it. 1 times 3a minus 4. 3a minus 4 is a common factor of 2a plus 1. I just replace the a with x squared back again so that I can solve for x. Now here, you might have been tempted to say this was a difference of squares, but 3 is not a square number, so we can't factor this further. We're just going to have to say 3x squared minus 4 equals 0, or 2x squared plus 1 equals 0. If 3x squared minus 4 equals 0, then 3x squared equals 4. Divide both sides by 3, x squared equals 4/3, and take the square root. Remember the positive or negative square root of 4/3. Now over here, if 2x squared plus 1 equals 0, then 2x squared equals negative 1. Divide both sides by 2, so x squared equals negative 1 over 2. And you might have guessed it, I can't take the square root of a negative number, right? So there's no solution here. So this provides me no information. This is the only solution that works. X is either negative root 4/3 or positive square root of 4/3. Those are the only answers that work, because I can't take the square root of a negative value. Okay, my next example, we're still solving by factoring. My equation is equal to 0. It looks tricky because I've x cubed. Well, I can't say that's x squared squared, so I can't do my trick from before. But look, each term has an x in it. So remember, this is where you got to remember to do common factoring first. The common factor is x. So when I factor out the x, I'm left with x squared minus 21x plus 54. This is a simple trinomial. I just need to put this into the factors. Two numbers that multiply to 54 add to negative 21. That ends up being minus 3 and minus 18. So x times x minus 3 times x minus 18 equals 0. So I just have 3 factors here instead of 2 factors. X equals 0, or x minus 3 equals 0, or x minus 18 equals 0. If I solve for x in each case, then I get my final answer. X equals 0, 3, or 18. All 3 answers solve this equation. And you know what I like about this? You can know exactly if you got the right answer or not. Take each of these values of x and plug them in for x one at a time and see if you get an answer of 0. If it works out, you know for sure that that's the right answer. Now I have 2 more examples for you, and they're a little bit different because you'll notice, this one anyway, has 4 terms. So we're not going to be able to solve it as a simple trinomial or a complex trinomial or difference of squares or anything like that. The only other thing that we know how to do is to factor by grouping, and so that's what I'm going to do here. group the first two terms and factor with the greatest common factor, group the second two terms and factor with the greatest common factor, and then just keep going. So the greatest common factor for the first two is 2x squared. 2x squared times x gets me 2x cubed. 2x squared times minus 3 gets me minus 6x squared. Okay, so 2x squared is one factor, x minus 3 is the other. For the second two, greatest common factor is 5. My other factor has to be x minus 3. Now, notice x minus 3 occurs in both terms, so x minus 3 is my next greatest common factor. So I've got x minus 3 as one factor, and I'm left with 2x squared plus 5 as my other factor. So now I know either x minus 3 equals 0 or 2x squared plus 5 equals 0. Solve for x in each case, and I get my answers for x. Now, because over here I'm taking the square root of a negative value, you can't have a solution for that. It doesn't work. So my only possible answer is x equals 3. That's the only value of x that solves this equation. This example is very similar to the one on the previous page, so why don't you pause the video, try this on your own, and then come back and see how you did. So I just factored by grouping again. Greatest common factor of the first two terms is 3x squared. I'm left with x minus 3 as the other factor. Greatest common factor of the last two terms is minus 2. I'm left with x minus 3 as a factor. Since x minus 3 is a common factor, I'm left with 3x squared minus 2 as my other factor. X minus 3 equals 0 or 3x squared minus 2 equals 0. If x minus 3 equals 0, then x equals 3. If 3x squared minus 2 equals 0, then 3x squared equals 2. Divide both sides by 3, x squared equals equals 2/3. Take the positive or negative square root. So I get 3 possible answers for x. Negative square root of 2/3, positive square root of 2/3, or 3. Now before I let you go, I just want to go over a little bit of terminology here. So if you have equations written in these forms, this is the kind of polynomial that we call it. So ax plus b, notice the degree on x is 1. This is linear. If the greatest degree is 2, this is a quadratic equation. If the highest exponent on x is 3, then that's a cubic. And if the highest exponent on x is 4, then this is called quartic. And if you go up to 5, it could be called pentic, whatever, but we'll just say polynomial of degree 5, polynomial of degree 6, and etc. Okay, so those are the words you need to be comfortable with: linear, quadratic, cubic, or quartic. We can factor all of those based on what we did in these examples. And now it's time to practice. So try some practice questions, or if you're not sure what's going on, if you need clarification, let me know and I will do my best to help.